We go. Welcome again. Getting started with Python. It's Friday afternoon for me. Uh, if you're watching a recording, it may be some other time. We plan to do this every Friday. I was hoping we would get through Python basics quicker, but I want to build a foundation in understanding Python before we get into test automation. But we may introduce more concepts as we delve into automation. In other words, the details about creating classes or splicing strings or something, we may cover briefly in the introduction, but we'll go into more detail about some more advanced things in Python. So let's get started. We're going to do a quick review. So we're going to look through the slides, right? Getting started with Python. Last week, we went through installing Python. We also went through using IPython to install different Python versions. You want to open up your command line, make sure you've got Python installed, and I'm going to go ahead and do that right here. I've got IPython, but you just type Python -v, and it should show your Python. The recent version that I have installed is Python 3.12.3. I'm going to be running from my Mac today instead of into Windows Virtual Machine. Python virtual environments, you can use PyEnv. I showed how to install that last week as well. I'll probably do a custom video on PyEnv specifically. Stands for Python environments. It allows you to have multiple versions of Python installed at the same time. You can download it here on Mac and Linux, or PyEnv Win for Windows. And that's handy for installing multiple versions. Now, pip is the Python package manager. You can install all sorts of programs, and I'll show you IPython really quickly. And it says all the requirements is already satisfied for me. Okay, next thing we want to do is we want to download Visual Studio Code. All right, so I'm going to open up a browser. All right, you see my browser? I want to make this nice and big. So you just want to search for VS Code. That's short for Visual Studio Code because it's a code editor. It's not really Visual Studio, but it's pretty cool. So you just download that and run your installer. But once you've got your installer run, we'll go through that in a minute. You can, in your folder from the command line, here's the URL for downloading. You can just type code dot, and we'll show how to use that really quickly. But here, I'm going to exit out of IPython here. So I'm in this Learn Python directory on my computer, right? Because I have Visual Studio Code installed, I can do code dot. And it's going to open Visual Studio Code. Let's see, here's my window. And it has print help. So we've used IPython. We've used the built-in Python shell in Visual Studio Code. I have that just maximized. So you can click this little arrow and it will run it. You can see it. It shows the full path to your Python install, and then it shows the full path to your file. That's this hello Python. And then it prints your output. So just to do that again, we've got a file. You can type print hello world here. Just to recreate that, and you click run, and your output here is hello world. And this is actually a terminal. Like I can use ls to list the contents of my directory, or dir if I was on Windows would do that. And it could be a PowerShell, it could be a DOS command. In this case, it is my ZSH or my Macintosh shell. Not Linux, not Windows. So this is another way you can edit. And when we're writing programs and we don't want immediate feedback, we will typically use a code editor. It doesn't have to be a VS Code. It can be Notepad. It can be whatever IDE or text editor you prefer. I also like using Sublime Text, for example. and that's just a way to run and edit code. I'm going to go through examples using IPython. Again, you can use the regular Python shell as well today. And so, hello world, right? We've gone through this. Let's talk about variables. So last week we introduced variables. A variable has a variable name. In this case, the name of the variable is name. It has an assignment operator. That's the equal sign. And it has a value. In this case, it's Aaron. We talked about strings and numbers as well. A string is any variable that contains text, right? We want text like my name is Aaron or hello world. You see those are all in quotes or quotation marks. It can be single quotes or double quotes. And I'm going to go back into IPython and replicate this, right? So I can do name equals Aaron. And I can print name. It is case sensitive. And the print function, the parentheses say put the arguments for a function here, print name, and I can also print, and I can combine two strings. So I can do hello, comma, and I can add or concatenate my name onto the end of that. So that says hello, Aaron. I can change name to something else. I can change it to Bob. And if I do hello name this time, it says hello Bob. No surprise there. Now I can have different types of variables, right? I can have an age variable. We went over this as well last week. And I can print my age. But if I try to print, if I print name plus is age, I'll get an error. It says can only concatenate string, not int to string. The way we solve this is, well, there's two things we can do. One, we can make age a string. So now I've got name is Bob and age is 42. And you can see they have quotes, single quotes or apostrophes or double quote marks. It doesn't matter to Python. You just have to be consistent. So I can't do age equals single quote 42 double quote. But I could do single quotes or double quotes. All right. So now I can print name is age. So, and then is also another string. I've got these extra spaces in between for formatting. And we can say Bob is 42. I can change the age. I'll change it to 43 and it'll say Bob is 43. I can change the name. I'll change it back to Aaron and print the name. Aaron is 43. So this is really basic. The only problem is I want to do things like I want to do age equals age plus 1. Concatenate string to string, not integer. So I want to change age back to an integer. And now I can do age equals age plus 1. And if I print my age, it's 43. And I can do the same thing again. Age equals age plus 1. My age is 44. I can even do age equals age plus 2 or 3. And I print my age, it's 46. So we're doing simple arithmetic here. But if we go back to print name is age, we get an error, a type error. That is because name is a string, it's text, and age is a number. You know what a number is. So the way to fix this is we can cast age to a string. So there's a function called str, which will take any value and it will try and convert it or cast it into a string. So it says Aaron is 46. Now I can do age equals age plus 2 again, and I print my Aaron is 48, and so on. we want to talk about types. So name is type string. So my name, the value of name is Aaron. And the type of age is int or integer, a whole number. There are other number types, right? So I could put temp for my temperature. Right? I can do 98.6 is my temperature in Fahrenheit. What's the temperature a human is supposed to have in Celsius? Anyone know? Doesn't matter. But if I do type of temp for temperature, it's type float. And we talked about this is a floating point or a decimal. The point is the decimal point moving around. So there's two different types of numbers basically, integers, and we can actually just enter a number. Type of 1 is int, or type of 1.2 is float, or type of, if we put 1.2 in here, it's going to be a string, and we can't add it. Now, in Python, you can actually do all kinds of math, right? So you can do 1 plus 1 is 2, and you can do 2 divided by 3. Now this is 0.6666. So this is interesting, right? If I do type of 2 and type of 3, they're both integers, but type of 2 divided by 3, or 2/3, it's a float. It has a decimal place in it. So it's actually converting the results there to a float. So if I did age divided by 3, it's going to equal a float, right? Type of age divided by 3. Now there are some more operators we can do. You know, there's plus, minus, multiply. The multiply is not like an X like the times. It's the asterisk key, you know, above the shift 8. So I can do age times 8 is 384. The division key is the slash or the fraction, and we can divide a number. By using division, by default, it's going to convert into a decimal unless we're doing, so we do 4 divided by 2. It's still going to be a decimal. But you can force decimals to be whole numbers, to be integers. Something else that's interesting is, so say I have 10. 10 divided by 3 is going to be a fractional number or a number with a decimal point. But we don't always want that, right? We want to round. There are functions to round, but you can actually do a floor function. So 2 slashes or 2 division signs will just give you the whole number, 3. And what if we want just the remainder? Does anyone know what that is? Other programming languages will use the same symbol for that. It's the percent sign. So the percent sign gives you the remainder. 10 divided by 3 has a remainder of 1. And we can even check that if we do 15 divided by, or 15 modulus, this is called, to give us the remainder, gives us a remainder of 0 because 3 goes into 15. If we do 16 divided by 3, we have a remainder of 4. I was going to do 15 divided by 4 is going to give me a remainder of 3. 15 minus 4 times 3, 12 is, yeah, 15 minus 12 is 3. I'm some trouble. So you can do all sorts of arithmetic operators. I believe, so I talked about types. My next category is, I guess I don't have operators yet, but we talked about conditions as well, but let's continue working with operators. So there are other operators besides math operators, operators that are used for comparison, and we want to use these comparison operators before we get into conditions and loops. One comparison operator is equals. So if you remember, we have a right, we have an equals. So using age equals 2, assigns the value 2 to the variable named age, and it tells us internally what the type of age is, right? Type of age, it's int. If we change age, if the age is 2.5 and we do the type of age has changed behind the scenes to a float. If we change the age to a string, the type of age is going to be a string. And remember, even a number in quotes is still a string. All right. Any questions on that so far? Am I going too fast, too slow? I know this is probably a review for those of you who've done it before, either from last week or in your own learning on Python, or other programming languages are very similar in terms of types. That there's usually an integer type, there's usually a string type. Assignment in most, but not all programming languages takes a equal sign. And I wanted to point out that the equal sign assigns a value. So how do we compare things? Like, is this number equal to, I think my age is still a string, right? Yep, so I need to change that. Age equals 42. We'll move this back. So now it's a number. I want to see, is my age equal to 43? I use two equal signs. This is the comparison, and it will return false. If I go to age equals 42, which is the correct value, it returns 2. So this is the comparison operator, two equal signs together. Now, there's an opposite to the equal sign, right? I can do age exclamation point equal sign. This exclamation makes it the equivalent of not equal to. You may be familiar, some other languages might have something that looks like this, not equal to, which looks more like, an equal sign with a slash, which you might see in math. But so this is a convention across many programming languages, including Python. The exclamation point and the equal sign means is not equal to. So in this case, age not equal 42 returns false, because if we print our age, well, it's 42. So then likewise, if we do age not equal to 43, now we know the value of our age is 42. So what we're saying here is age not equal to 43? The answer is true. Age is 42. 42 is not equal to 43. So this expression, an expression is something in the programming language that evaluates to something. An assignment is an expression. A print statement is technically it's an expression. It's a function call. But this expression, age not equals 43, evaluates to true. We can also use greater than or less than. If I say age is greater than 43, it returns false. 42 is less than 43. If I do age is less than 43, it evaluates to true. I can also do age less than or equal to 43, which is true, which also evaluates to true, less than or equal to 42. It is equal to, so it's true. So regular math operators, a little bit of different syntax. The two equal signs means is equal to. The exclamation point equals means not equal to. And then greater than, less than, no surprise. But you do greater than equal or less than equal. Age is less than or equal to, or wait. I had less than, now I'm comparing greater than, equal to 41, and that's true. So greater than and equal and less than and equal, very similar. One more math expression that's also useful is exponents, right? So if I want to do like 3 squared, I would do 3, 2 with 2 asterisks or 2 multipliers, right? So that's essentially saying 3 times 3. 3 times 3 is 9, right? So 3 squared. And if I do 3 cubed, 3 to the third power is 27. And if I do 2 to the 10th power, that's 1024, or 1 kilobyte, or 1 kilobit. um, Depending on what the 2 stands for. So the two, essentially 2 multiplication signs times is an exponent. That's probably enough for math expressions. Well, actually, there's one more thing I want to introduce. So let's clear the screen. I want to show how you can import something. In Python, there are a lot of different packages. For instance, you can import OS. Yeah, OS name. In this case, it comes back as POSIX. So my Macintosh or Linux machine. I think the OS name would come back possibly as Windows if you were on a Windows machine. It's worth trying. So we imported the OS for operating system module. We can also import a math module, right? So there's, I type import math, and then I can access some other numbers like pi. This is an approximation of pi. And I can do math.square root of 100 is 10. So the square root of 100 is 10. You can see we're taking the square root of a integer and it returns a float, just like division. And math dot square root of 4 is 2, and so on. Even the square root of 1 converts 1 to 1.0, which is a float. Let's talk a little bit more about strings before we go into loop, right? So strings, if you remember, this is a string, and we can check that from here. This is a string, is an str or string. These are the 2 main types, right? We have numbers, which can be floats or integers, and strings. There are some other types as well that we'll get into later. So for strings, name is a string, right? Okay, and I've got name here. We can access a string. Is the name string is probably curious. It means a string or a list of letters, right? This is a string of letters tied together, AARON. So we can access each of these individual variables within a string. So we can do name, and then we use square brackets. We can say the first letter in string is A. But there's one thing I want to show. Python uses zero-based indexing. I'm not sure if we went over this last week. So when you count the letters in a string, so this one would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever, 15, something like that. Aaron has 5 letters. It has a letter at 0, a letter at 1, a letter at position 2, position 3, and position 4. Most, but not all, programming languages have an index that starts with 0, and it's used for strings, lists, arrays, whatever types like that. So that's something I wanted to show you. Again, to stress, the single quotes or the double quotes don't matter. You just have to be consistent with those in Python. We talked about putting strings together, right? So if I'm doing hello plus name, I'm concatenating 2 strings together, and it returns 1 string. So I could make greeting equals hello plus name, and now greeting greeting actually contains both this string literal hello with a space on the end and the value of name. If I change name to, I change name to Bob again. Greeting is still going to say hello, Aaron. I can reassign it and it'll say hello, Bob as well. So it doesn't, one string does not change the value of another string, even if the variable was set before. The ability to do that will come in handy in other cases, and we'll get to those much later. All right, there's also some cool other tricks you can do with strings. So for instance, I can print greeting times 3. Any guess on what that's going to do? It's going to print hello Bob, hello Bob, hello Bob. So we can use multipliers, and we could even go 100 times or 1,000 times. And it gets really kind of ridiculous. And because there's no space at the end, it looks like Bob, hello, Bob, hello, Bob, hello. So that's a cool thing that you can do with strings. So some other things we can do is, remember, if we have age as a string, we can't do age equals age plus 1. But just like we can coerce a integer into a string, we can coerce or cast a string into an integer. So an age is still a string, but I can do age equals or assign here, and now my age is an integer. But if I tried to do name equals int name, we got my equals sign, what's going to happen? It says invalid literal. In other words, Python doesn't know how to turn Bob into a number. Here's something I'm not sure if Python does automatically. What if we have a variable called price, and price is $1.25? That's perfectly fine, and we can print our price. But can we convert that to an integer? Nope, we can't. But, so price is a string. I wanted to show you how to, we can remove or replace. So if we do price dot replace the dollar sign, we can replace that with an empty string. So now our price is just 125. Oops. It didn't change it because we didn't assign the value. It created a new variable that just went to the output. So if I do price equals price, replace, now I can, we can't do int, but we can make a float of it. So let's check something here. Float 124, sure. We still can't convert. But if we do 124 dot replace dollar sign with empty string, now we get, and then we can do things like we can multiply by 5 if we want to get 5 candy bars for 620. Oh, we can also take strings, like, so my name is Bob. We can use upper on name. All right, we can do name dot upper. So we can convert it to uppercase. Likewise, let's see, our name is Bob. We can do name to upper, and it's not going to save it because we're not assigning it. But we can do name lower, and we can make it all lowercase. If we had a string with spaces at the start and end, let's put some extra spaces in here. We can, just call this S. We can do s.trim. Wait, is it strip? There we go, strip, not trim. Other languages have a function called trim, but we removed the spaces from the start and the end here, which is also useful. We can also get the length of a string. Now, this is kind of an inconsistency. You would think you could have length be a function on string, but length is a standalone, and we can get the length of a string, or we can get the length of name. Bob should be 3. And then lastly, we can split string. Well, not lastly, but we can split strings. So we'll split S, and we'll split it based on the space. Oops. We're going to do S dot split in this case. So we're splitting it at every space. And now we've got this empty one with spaces at the start and end. And then you've got these extra ones. So this is the space, but there's no space in between here because it's taking this. And I believe the option is, there is an option to keep it. In IPython, there's built-in help. So I can do split ? And it will tell me the built-in help for this. Separator is none, or max split equals -1. So I could split with a space, and then I can say I only want 2. So it broke it up into 2 pieces. Or with them, it did a maximum of 2 splits. This empty string at the beginning, I thought there was also an option to not remove the separator character. I'll have to look into that. Let's talk about lists. So I hinted at lists here. A list is, as you might expect, let's make a variable called a list. So L equals list, and we'll just add 3 integers here. We talked about how a string has an index, right? So the first index of name is at 0. That's B for Bob. A list also, like a string, has an index, so I can get 1 here. Or if I had another list, right? I wish I hadn't typed this as something so long. I can get the 0, 1, 2 index item, which is Baz, from another list. Likewise, I can get the 1 or 0, 1 index, or the first one, the 0 index of the list. Notice here we have L is a list of strings. I mean, a list of numbers, and another list is a list of numbers, right? So if I do type of L, it's going to say list. If I do type of L sub 1, 0, 1, that's going to be the number 2. It's an integer. I'm going to make M equal another list. So now I'm assigning the value of another list to a new variable, M. Type of M is list. We can see M, it has foobar Baz. We can see L, it has 1, 2, 3. So type of M sub 1 is going to be string, or str. Type of L sub 1 is int. And lastly, we can create a list with different types. So we can have 1 word, and we can actually have a list of lists. So now we have the type of N is a list. Let's take a look at N. N n sub 0 or index 0 is 1, n index 1 is word, and n index 2 is this nested list. All right, so, and we can see that type of n sub 2 is also a list. This is getting a little bit complex, but we can also go to n sub 2 sub 2, and that's actually going to be 0, 1, 2. So n sub 2 gives us this, 0, 1, 2. And then we can actually take that first list and get the index of the element 0, 1, 2. So we'll get this here. And they're all ones, so it's no surprise that it's. So we're getting a nested list or a two-dimensional list. What can we do with a two-dimensional list? Well, let's create a list of users, right? So we can create people, and I can create a list, and it's going to we're going to have a name, and we're going to have an age here. We'll call this one A. We'll create another one, we'll call it B, and we'll call him Bob, and we'll say he's 23. And we'll create another one, Charlie, and he's 66. So we've got a list of different people with different ages, right? I can get A sub 1 will give me the age, A sub 2 will give me my name, and oops, I meant to use B sub 0 is Bob, B sub 1, and sub is just a shorthand expression for the index of. It'll give us Bob's age, 23. So now we can create a list, and we can call it people, and we'll create a list of lists, A, B, C. Now let's go ahead and take a look at people. You can see here we have these brackets which indicate the outer list of people, and then it has these inner lists, Aaron, Bob, and Charlie. So now we can say, I want people, I want the first person, that's person sub 0, and I want to get the name. So person sub 0 is A, it's going to be Aaron. Person sub 2 sub 1, what is that going to be? Person 0, person 1, person 2 is this one. The 0 index and the 1 index and Charlie. If I've done my calculations correct, we should get 66. All right. So what's the purpose of a 2D list? Let's try and visualize this another way, right? I'm going to, I'm trying to, guess I need to make a new window here in, I need to create another window here so that I can move my Excel sheet in here, right? So this is the equivalent of Aaron, 42, Bob, I don't remember his age, Charlie, 66, right? So this is a two-dimensional array. 0, 0, 1, 1, 2, 1. And we could put some other values in here, right? We could say Aaron is a teacher, Bob is a student, and Charlie is administrator. So how would we do this if we wanted to go back into Python to do that? Well, we could actually do Aaron append teacher. So now we look Aaron. Now I have 3 values, Aaron, 42, and teacher, and we can do Bob dot append student. We can see B is Bob, 23 student. And C, append. We'll make him the administrator. And there's Charlie. Charlie is 66 and he's the administrator. But now we go to people and we can see, because each of our individual lists, remember this didn't happen when we were assigning or when we were modifying a string that it contained another variable. But a list contains, well, the way we created the list with A, B, and C as our variables, it contains pointers to these other variables. So now we have the same thing. If we look in Excel, right, we have Aaron, Bob, Charlie. So if I want to do, if we were to change the numbers here, if this said 0, 1, 2, and if this said 0, 1, 2, so C3 is equivalent to 2, 2 in the index here. So we can go people to 2, and we can see Charlie is an admin, and that gets us right. A two-dimensional list is really handy because it allows us to essentially treat our code, our data, like a spreadsheet. There are actually even better ways to do this with Python, and there are ways in Python that you can actually import and export from Excel fairly easy using a library called pandas. We won't get into that though. Let's do conditions on lists. We talked about basic conditions, right? So a basic condition, right? If A, well, we've got, we need to assign some variable. Let's do X equals 1 and Y equals 2. Because A and B are the lists, Aaron and Bob. Right, so we've got X is 1 and Y is 2. So now we can say if X is greater than Y, we can print something. Yay. If this runs, it runs and it prints nothing. Why? Because, well, X is 1 and Y is 2. So X is not greater than Y. If we change this and we say if X is less than Y, print yay. Oops. This is something with IPython. I've got to kind of get to the end of this. Then we print yay. So it evaluates this expression. Remember, the operator, well, let's look down here. The operator is less than. The expression is X. So the expression evaluates to true or false. Is X less than Y? So it evaluates to true. So if true, colon, print yay, and that works. We could even do if X plus 1 is less than Y. What are we going to get? Go down here. We get nothing. Why is that? Well, X plus 1, 1 plus 1 is 2. Is 2 less than 2? No. Again, we can change that. We can make it less than or equal to. And in this case, yay, we print yay. So that's a little trick of doing that. A condition starts with if. Not always, but most of the time you're going to use if for writing a condition in Python. And then you're going to have your expression. In this particular case, we don't need parentheses. And I actually wanted to point out parentheses are used for order of operations in Python. So, right, if we have 1 plus 2 times, let's do this, let's do 3 plus 2 times 4. That comes out to 11. Why? The order of precedence. Just like math, it does multiplication before addition. 2 times 4 is 8. 8 plus 3 is 11. But we can also use parentheses, just like in our math that we learned when we were young. And now, why is it 20? 3 plus 2 is 5, is evaluated first, times 4 is 20. We can do the same thing in our conditions. So let's go back to our. Let me do if 1 plus x times 2 is greater than 5. We'll just use 5. Print yay. Yeah. All right. So let's evaluate this. X is 1, so 1 plus 1 is 2. 1 times 2. I need to get better at my math. 1 times 2 is 2, plus 1 is 3. 3 is less than 5, so this evaluates to false, and this section of code does not execute. Let's do this a different way. 2 times x. Let's use y. Here we go. Y is 2, right? So y times 2 is 4, plus 1 is 5. Is 5 greater than 5? No, they're equal to. So we don't print yay. All right. But we can use order of operations. And again, we don't need the parentheses on the end. Now, 1 plus 2 is 3 times 2 should be 6 is greater than 5. Yay, we got it right. The last thing I want to show with conditions, and it's probably a good thing to end on for today, is we can also we can use else as an option. So if this expression evaluates to true, we execute this code and we print yay. Else, or in other words, if this does not evaluate to true, we print boo. Oops, I forgot a quote sign here. So let's go ahead. I messed myself up again. Here I cleared the screen, but it still had this in the buffer. So because this evaluates to 6, 6 is greater than 5, print yay, else print boo. If we remove our parentheses, it's going to evaluate to false and execute, skip over this section and execute this section. Oops. We get boo. I'm going to throw one more twist in here. I'm going to do 2 twists before the end of the day. I'm going to introduce you to not. Not is a key word that flips it. So this expression, I don't remember. This evaluates to false. Yeah, let's see. Y times 2, 2 times 2 is 4. Let's simplify this. 1. So this is going to print yay instead of boo, because while this expression evaluates to true, it's like saying if not true. True is a keyword as well. And I'm going to talk a little bit more about this. Print, yeah, let's do lies. So if not true, print lies. If true, print lies. So this is all right, if true, print let's do this. Print honest, else print lies. All right, so true evaluates to true. We're going to print honest instead of lies. All right. So now we can say if not true, print honest. Well, nope. True evaluates to true, but not true flips it, so it evaluates to false, and we get lies. All lies. We can do the opposite as well. So we can say if not false, print honest, else print lies. Well, not false equals true, so we print honest. And if we start with just if false, false evaluates to false, So it's going to skip over this part and go to this part. False, lies. What I wanted to point out is you can have complex expressions, right? This can get tricky. We need to back this up. Oh, this is one thing I also need to bring up. In Python, indentation is actually important. If you don't have proper indentation, you will get an error. All right. So, for those of you who have a truly dizzying intellect, if not false or not true, print lies, else print truth. If either one of these evaluates to true, we print lies. Does not false evaluate to true? Yes. Does not true evaluate to true? No. So we have a true statement and a false statement. But if either one of them is true, we execute this first section. Otherwise, we execute the second section. Now, let's introduce one last thing and then we'll end it for today. So if not false and not true, what do we got? Oops. We get truth. Here's how this works. Not false evaluates to true, and not true evaluates to false. In this case, both of these need to be true in order for us to print lies. Wait, this is too confusing. Let's reverse the order here. We'll just do correct and wrong. And we're going to replace false if not 3 greater than 2 and not 2 greater than 3. What do we got here? So 3 greater than 2 is true. Not true is false. 2 greater than 3 is 2 greater than 3 is false. Not false is true. So we have false and true. Are both false and true true? No. So we'll print wrong. And then lastly, if we change this to an or, if either one of these is true, let's remove our nots. That just makes it too complicated. So if 3 is greater than 2, or if 2 is greater than 3, print correct, else print wrong. And we get correct. And the last thing before we stop here, are these both true? Is 3 greater than 2? And is 2 greater than 3? We get wrong. All right. We didn't even get to functions today, which makes me sad. We didn't get to functions. We didn't get to loops. But we're going to cover more Python next week. I was hoping by next week that we would get into writing test cases. So I'm going to stop the screen share, and now we got a few minutes for feedback. What do you guys think? Am I getting into too much detail? Am I not explaining things clearly? Or do you just want to get into like automating browsers and stuff?
No, you are going very thorough, and everything is in detail, so it's making me sense, and I'm learning a lot from there.
Okay, great.
Yes, Aaron, because I'm new to Python, so just from the scratch you're going. That's so helpful.
Okay. Are you guys following along, and if not doing exactly the same thing, are you typing in commands and testing them out yourself?
Yep. I'm trying out. Yeah.
Okay, great.
Yes.
Do you feel like I'm going at a decent pace, or is it either too slow or too fast for you to follow along?
No, you are going good.
Okay, great. Thanks for that feedback. The complex expressions, like this, if not true and not false, what I wanted to show is that there is ways to do that, but good programming technique is to write your code in a way that's simple. So to not use complex expressions to evaluate. That's something that while I demonstrate these complex conditions to show how they work, we normally want to avoid them. So if you find something that is hard for you to parse mentally, it's probably worth spending some time as you're writing your code to see if you can find a simpler way to express it. And that's probably, once you've understood the basics of a programming language, that's the next level, is understanding how to keep it simple. All right, any other questions or comments?
No, so far so good. So I'm going to see this video again on the same area, right?
Yes, I'm going to post this on the OneShore YouTube channel, and I'll send out a notification as well.
Okay, sounds good. Thank you so much.
Thank you.
All right.
Okay.
All right, you all have a good day.
You too.